Dear students, we have arrived to the ninth part of the video series dealing with the public balance and government debt. Now we are going to take a look at the government debt changes on the long run through a calculation example. I would like to show you how the changes over several years can be captured, how we can calculate and interpret the variation of the government debt as a percentage of the GDP, and further analyze what factors influence this ratio. So we are going to model the factors influencing the government debt on the long term, and the exercise sounds as follows. The nominal GDP of a country was 42,000 billion forints last year. The government debt as a percentage of the GDP in the same period was 80%. Within the total amount of government debt, 20% was denominated in foreign currency. Last year, the average interest rate of the government debt in national currency was 2.5%, while the interest rate of the debt in foreign currency was 1.5%. We also know that last year the average exchange rate of the national currency, the forint, to the euro was 300 forint, while the exchange rate this year is 309 forint. Obviously, from this data, we will be able to determine the percentage value of the exchange rate change, the epsilon. The primary balance last year showed 200 billion forint surplus, while this year the primary balance was 0 forint. The government had a single-time exceptional revenue of 1,000 billion forint. To the following years, no exceptional revenues or expenditures are expected. The economic growth of this year is 2%, while the inflation is also 2%. Furthermore, we also have a table where you can see the estimated values for the next years. So the data of the last and this year are placed in the written part of the exercise, and we also have data for the T+1, T+2, T+3 and T+4 time periods. T+1 shows data of the next year, T+2 the data of 2 years later, T+3 refers to 3 years later, and T+4 shows the values of 4 years later. Obviously, this can only be estimated values since no one knows the exact future value of this or that data. On the second column we can see the data of the inflation marked with P. The economic growth rates are marked with G. These represent the changes of the real GDP, as we already know, followed by the data of primary balance, PB, where the negative values refer to deficit. Throughout the years, the rate of the debt in foreign currency can also change. The changes can be seen in the fourth column marked with A. Furthermore, the interest rates can also change. ID refers to the interest rates of the debt in national currency, and IXD refers to the interest rates in foreign currency. And in the last column you can see the forint-euro exchange rate, which can be either determined by taking the average value of the daily averages for the whole year, or by taking a single day's average exchange rate, most commonly the 31st of December. Either way, in this column you can see and follow the weakening or strengthening of the national currency. Alright, so these were the data, and let's see now what are the questions of the exercise. The first is to fill in the red cells of the table below, both dark and light red. Soon you will also see that table. The second is to calculate the values of those green cells that are necessary to determine the ratio of the government debt to the GDP 2 years later. And finally, and this is the essential part, to determine the ratio of the government debt to the GDP in the time period T+2, so 2 years later. So now we are not taking into account only 2 years, but also 3 years. Obviously, with the same method, we could also count the data of T+10 or T+100, but since that would be very time consuming, we are just going to focus on the methodology itself. How you can determine the dynamics of the government debt through several years and interpret the complex processes. And so here is the table that we have to fill in. Dark red refers to the data of last year, it's T-1, which we shall give in according to the exercise text. Yellow cells also refer to the last year. However, these indicators have no future influence regarding the dynamics of the government debt, so these do not have a significant role, and therefore we can also leave them out. Light red cells will include those data that were again given in the exercise, referring to this year and the upcoming years. And finally, green cells refer to such values that will have to be calculated. From the calculated values, so from the green cells, only those need to be determined that are necessary to calculate the ratio of the government debt in the time period T+2. This cell is highlighted with blue. This is going to be the key question. So let's see the solution of the exercise. First, we will need to fill in the red cells, those data that were already given in the exercise. If we go back to the text, we can find this here. The nominal GDP of last year, that is epsilon t minus 1, which was 42,000 billion forints. The ratio of the government debt last year was 80%. This is d t minus 1, which is 0.8. 20% was the rate of the debt in foreign currency, that is a t minus 1, which is 0.2. Average interest rate of the debt in national currency was last year, this is IIDT minus 1, and the interest rate of the debt in foreign currency is IXDT minus 1, which is 1.5%. The 300 foreign exchange rate will be placed in the euro foreign column for the time period T minus 1, since it is the data of last year. The primary balance showed 200 billion foreign surplus last year that will be given in the PB T minus 1 cell. Furthermore, the government had exceptional single-time revenues in the value of 1,000 billion forints for this year, that is ODT. And last but not least, the economic growth was 2% and the inflation rate was 2% as well. From all this information, we can fill in all of the red cells and then the green cells, so the calculation will follow, whose methodology I am going to present now. First of all, epsilon t, the nominal GDP of this year. This is a very simple task. You can easily calculate it if you multiply 1 plus g with 1 plus p and epsilon t minus 1. Both the g and p are 2%, so the multiplication will be 1.02 multiplied by 1.02 multiplied by 42,000. If we round up the result, it will be 43,697, obviously billion forints. We can calculate epsilon t plus 1, epsilon t plus 2, and so on very similarly. You can see the solutions here. Epsilon t plus 1 will be 1.03 multiplied by 1.025. These are the economic growth rates and the inflation rate of the time period t plus 1, multiplied by 33,697, which was the nominal GDP of this year, so epsilon t. If we make the calculation, the expected nominal GDP for the next year will be 46,133 billion forints. The value of the nominal GDP for the period T plus 2 can be calculated the same way. Here is the solution with 48,039 billion forints. Lowercase pb is also a calculated value, but it is also very simple. You can calculate lowercase pb, which is the primary balance as a percentage of GDP, by simply dividing pb by epsilon, so the primary balance by the nominal GDP. If we are looking at the T period, we can see that the primary balance was 0, so no matter what the value of the nominal GDP is, the ratio will be also 0. You can also calculate this value for the periods T plus 1 and T plus 2. You can see the solutions here. So these were the preparatory calculations, and from now on the task is to calculate the T plus 2. So the ratio of the government debt to the GDP in the second year. We are going to do this by proceeding row by row or year by year, starting with dt. For this, we need to apply the formula that we already know from the previous videos. A1 minus a t minus 1 multiplied by 1 plus I id t minus 1 plus a t minus 1 multiplied by 1 plus I xd t minus 1 and multiplied by 1 plus epsilon t divided by 1 plus gt multiplied by 1 plus pt multiplied by dt minus 1 minus pbt and odt. Again, we can say that it sounds quite complicated, however the markings are pretty obvious. If we manage to fill in the table, we just have to take a look, find the right information and substitute it to the right place of the formula. In the case of 1 minus a t minus 1, a t minus 1 was 0.3, so 1 minus 0.3 will equal 0.7. This is multiplied by 1 plus id t minus 1, which is 3%, so 1.03. And so on further, substituting the right values. As a result, we will get the ratio of the government debt to the GDP, which is in the t time period 77.4%. Then we will move on to the next year. When we analyze the period t plus 1, it is very important to update the formula. Actually, this is the point where you can get lost. We are looking for the ratio of the government debt in the period t plus 1, where the previous year's values are not t minus 1, but t. As you can see, 1 minus at, we are taking into account a in the t period, which was 20%, so the result will be 1 minus 0.2, that is 0.8. id in the t period was 2.5%, so we are going to multiply 0.8 by 1.025. Then it is followed by at, this is 0.2, and I xdt and epsilon t plus 1, the change of the exchange rate. A few thoughts on the exchange rate. This is also a calculated value, however it is very simple. You can calculate the epsilon if you divide the exchange rate of a given year by the exchange rate of the previous year and subtract 1 from the result. So for the t period you need to divide 309 by 300 minus 1, that will equal 0.03 or 3%. Here we need to use the epsilon t plus 1, which you can calculate by dividing 315.18 by 309, that is 2%. So going back to the formula, dt is the previously calculated debt ratio, 77.4%. And then finally we subtract pbt plus 1, the ratio of the primary balance of the given year, which was 0.5% or 0.005, and odt plus 1, which was again 0. When we calculate the result, it will be 0.758, or in other words 75.8%. And very similarly, you can also calculate the ratio for the next year. So for the t plus 2 time period, the dt plus 2. Here the previous year will be t plus 1, and we need to find the right values from the table above. So a for the t plus 1 period is 25%, so 1 minus a will be 75%, or 0.75. id t plus 1 was 2.8%, so the second component of the multiplication will be 1.028. To this we will add 0.25, which is a t plus 1, multiplied by 1 plus I xdt plus 1, which is 1.025, and multiplied by 1.01, which is 1 plus epsilon in the t plus 2 time period. This is multiplied by the government debt ratio of the previous year, 0.758, and we subtract the primary balance ratio of the given year, that is minus 0.6, and the ratio of the other factors, or the t plus 2, which is again 0. If we round up the result, it will be 0.756, which means that the government debt compared to the GDP in the t plus 2 time period was 75.6%. If we calculate these kind of exercises, it is sure that the markings and definitions will become clearer and clearer, and the logic behind the government debt will be discovered. And once we achieve this, we can further work with it and further analyze the problem. We can also present the factors influencing the government debt in an Excel sheet and leave out all the background calculation. We only need to fill in the red cells, and in the green cells every calculated value will appear, since we can program these formulas in advance to the Excel sheet. The main point would be for you to be able to use such an Excel table. You can try to determine the future values of the government debt ratios, follow the changes, or forecast the future economic growth or inflation. Or if such projections exist, you can also use their data to calculate the future processes and make long-term estimations. Thank you for the attention.